Black Hole Part 4. Who discovered black holes? An English cleric and amateur scientist named John Michell in 1783 showed that Newton's law of gravity suggested that objects like black hole could exist, and they could only be detected if they happened to have a star in orbit around them. He used the term dark star to describe black holes, whereas physicists, on the other hand, used to call it a gravitationally collapsed object. An American astronomer, John Wheeler, coined the term black hole, and the first one was discovered in 1971. With the general theory of relativity, Albert Einstein predicted the existence of black holes back in 1915. Unlike the laws of gravity given by Isaac Newton, Einstein perceived gravity as a distortion of space-time. In 1970, Paul Merton, an English astronomer, contributed to finding the strange invisible objects that emit X-rays. He began searching for a binary star system in the Cygnus constellation at the Royal Observatory in England. He discovered that one star in the binary system gave off no light and had other in its orbit. Merton's observations revealed that the invisible partner had a mass 6 times the mass of the Sun, clearly making the star a black hole candidate. He presented a paper along with his colleague, Louise Webster, stating Cygnus X1 might be a black hole. Can black holes collide? Two black holes can collide. They can collide and send ripples through the space-time fabric of the universe that are called gravitational waves. Once they come close enough, they cannot escape each other's gravity, and they will merge to become one bigger black hole. What is event horizon in a black hole? Event horizon, or as we call it, point of no return, is the boundary of a black hole beyond which light cannot totally escape because the gravitational pull of the massive object becomes so high as to make escape impossible. Any object approaching the event horizon never actually crosses it from an observer's point of view. Instead, it becomes more and more redshifted as time elapses. This means the wavelength of the light coming from the object becomes longer as it moves away from the observer. This phenomenon of shifting of wavelength of light is known as Doppler effect. What are the types of black holes? 1. Supermassive black holes, SMBH. 2. Stellar black holes. 3. Intermediate mass black holes, IMBH. 4. Miniature or mini black holes. Supermassive black holes, SMBH, or sometimes SBH. These are the largest among all, accounting to a mass of the order of hundreds of thousands, to billions of times, the mass of the Sun. The average density of a supermassive black hole can be less than the average density of water, in some cases. This is because the Schwarzschild radius is directly proportional to its mass. If observational pieces of evidence were to be believed, every galaxy has its own supermassive black hole right at the center. According to astronomers, the Milky Way contains a supermassive black hole which corresponds to the location of Sagittarius A, 26,000 light-years away from the Solar System. Stellar black holes, SBH. Stellar black holes have masses ranging from about 5 to several tens of solar masses. The formation of a stellar black hole is observed as a hypernova explosion, or popularly known as a gamma-ray burst. A black hole has 3 properties, namely, mass, electric charge, and angular momentum, spin. It is generally believed that all black holes in nature have some spin. The spin of a stellar black hole is due to the conservation of angular momentum of the star or the objects that produced it. Our Milky Way galaxy contains several stellar black hole candidates who are closer to us than the supermassive black hole. Intermediate mass black holes, IMBH. Intermediate black holes have masses in the range of hundreds of solar masses. Significantly more massive than stellar black holes but smaller than supermassive black holes. Many IMBH have been observed in our galaxy and nearby. Miniature or mini black holes. These are also called quantum mechanical black holes, or simply micro black holes. In 1971, Stephen Hawking gave a concept about the existence of smaller black holes than stellar mass. According to him, Mini black holes are not black in fact. They evaporate with time, approximately following a black body spectrum radiation. The evaporation rate is inversely proportional to the black hole mass. They are hot, unimaginably hot. Some theories suggest that miniature black holes might have formed during the Big Bang or at the early start of the universe. These might have been formed between 10 and 20 billion years ago, where so much energy was compressed into a single point. These tiny individual points exploded and expanded rapidly, where some parts grew more quickly than the others, giving rise to mini black holes.